Good afternoon, class. Today we're looking at piecewise and quadratic functions. I think we're going to take the quadratic functions portion of this assignment and discuss that first, okay? Let me switch over to paper. I need to do some writing here. And hold on there, and that looks good. Okay, I better move this. We graphed quadratic functions weeks ago in that first section involving graphing. Remember, we said a quadratic function is any, back then we just called it a quadratic expression, but now we have that word function or equation. It can be written as y equals or f of x equals. Remember, f of x is just a fancy way of saying the variable y. Ax squared plus bx plus c, where a doesn't equal 0. If a were 0, you wouldn't have that x squared term. So a cannot be 0. We saw when we were graphing these things the first time that the graph is a smooth U-shaped figure called a parabola. Now, we're only going to graph these U-shapes that open upward or downward, because we're only graphing parabolas that are functions. If we had a parabola the last time when we were looking at the vertical line test, we had a parabola laying on its side, a horizontal parabola. One laying like that is referred to as being horizontal. And we said that's not a function. It fails that vertical line test. So we're not going to be graphing any horizontal parabolas. The only ones we're going to be graphing will be vertical parabolas.
In fact, I think functions are the only thing we're going to be graphing the rest of the semester.
That's right. We won't be graphing anything that's not a function for the rest of the semester. Now, this is different from that absolute value graph where there was that sharp point. This has a smooth, it has a vertex, whether it's opening upward or downward. It has a point where the graph changes directions, and that is called the vertex. But it's a smooth turnaround. There's not a sharp point. If the parabola is opening upward, then you expect the a value, the leading coefficient, to be positive. So when I look at the function, when I look at that number in front of x squared, if it's positive, I expect the parabola to open upward. If it's negative, I expect the parabola to open downward. And we're not going to be graphing any of these horizontals because they fail the vertical line test. With a absolute value function, we had a way of determining the vertex by asking ourselves, when is the step inside the absolute value equal to 0? Here, there are two different approaches for determining the location of the vertex of a parabola. One of them requires completing the square. That's never, the way we did with circles, that's never very quick. The other way uses something called the axis formula, the vertex or axis formula.
Y'all remember the quadratic formula? Did y'all get it started? X equals...
What's the first thing that goes up here? More than b. There's something in front of the b. Negative b
plus minus square root of b squared minus 4ac
all over. What's the denominator of the quadratic formula? 2a. There it is. There's the axis formula. This vertex or axis formula is just the quadratic formula without all the messy stuff. Just the negative b and then over 2a. Now, we graphed vertical lines weeks ago, and we said that the equation of a vertical line would have an x and no y. And the axis of a parabola is the vertical line that passes through the vertex, so that if I could pick this piece of paper up and fold it down that dotted line that I drew, the right-hand side should lie directly on the left side. They are symmetric about that vertical line. Likewise, there's the vertex. And just imagine if you fold the paper down that dashed line, the right-hand portion should lie directly on the left-hand portion. So to use the vertical graphing tool that we're going to have, it's similar to what we did with the absolute value graphing tool. To graph vertical parabolas, what you'll have to do is, once you click the vertical parabola graphing tool, I guess I'll write that down, click graphing tool, it's the one for vertical parabolas. Then you'll have to label the vertex. So you'll use that vertex or axis formula to label the vertex. And then it's going to ask you to plot one additional point. So when I'm getting ready to graph a parabola, all I'm going to do is I'll find the vertex. I'll use the little axis formula to get x. And then how will I find y? Once you know x, you're given a function. Once you know x, how do you find y?
3 words.
Plug it in.
Oh, okay.
So we'll find that the location of the vertex, the x coordinate, plug it into the function they give us to find the y coordinate.
You know what, Tim?
But then we have to use one additional point.
Instead of writing 3, why don't you write find minus b over 2a and plug it in?
Okay, so that's how we'll find the vertex. Find minus b over 2a and plug in. Then third step, you have to find another point. Find another point.
That's how you did it with the absolute value tool. Remember?
I remember that.
You found the vertex, but you didn't use a formula, and then you found one other point.
When we're looking at a vertical parabola, the vertex will either correspond to the low point on the graph or the high point on the graph. If the vertex is the low point on the graph, that means that has the smallest y coordinate. Every other one of those points here will have a y value bigger than that y coordinate of the vertex. So in this case, when a parabola is opening upward, we expect the vertex to correspond to a minimum value. When a parabola is opening downward, apply that same logic. When a parabola is opening downward, the vertex is at the lowest point on the graph. What is it?
Another word, M word.
It's the highest point on the graph, and so we'll say that the y coordinate at the vertex when it's opening downward is the maximum y value. So, when looking at quadratic functions, the maximum or minimum function value, I'm going to write that down. The maximum or minimum function value, and remember the function value is the y value, occurs at the vertex. That's important because there are some word problems here in this assignment dealing with quadratic functions. They'll be asking for maximum or minimum values. Well, if you're looking at a quadratic function, maximum and minimum values occur where? At the vertex. So you'll have to use the vertex formula. We'll do some of those word problems in a moment. There's one other thing. I know I'm telling you a lot of stuff right here, but there's something else I need to discuss. The domain and range of a quadratic function. When we look at this function, ax squared plus bx plus c. We found domains of functions like that the last time. Look at where we are, right? What's right up here? Wouldn't this be a quadratic function? It has that x squared. What did I say? No square roots, no denominators. What do you assume the domain is? All real numbers. A quadratic function, any quadratic function, whether it's opening upward or downward, will always have the same domain. The domain of y equals ax squared plus bx plus c is always negative infinity to positive infinity. So they'll be asking you when we're going through analyzing these quadratic functions, they'll ask you what's the domain. Well, it doesn't matter what the problem says. If it's a quadratic function, the domain is going to be all real numbers. Now for the range, that takes a little bit more effort. Let's look at the two possibilities. You can either have a parabola opening upward or downward. Let's say that, I think for this example, I'm going to just make up two numbers as the coordinates for the vertex. I think I'm going to say that's the ordered pair 1, 2. Ordered pair 1, 2. Is this vertex corresponding to a maximum or a minimum? A minimum because it's opening upward and the vertex is the low point. What is the minimum y value on that graph? What's the smallest y value that appears on that graph I made up there? 2. And then every number bigger than that is used as a y coordinate. So we would say the range, 2 is being used, so bracket 2 to infinity. That's not good. In general, if a parabola is opening upward, the range will be in the form, that's not any good either. You'll have a bracket. It's the y-coordinate of the vertex, whatever that y-coordinate of the vertex is. So, y-coordinate of vertex, comma, it starts there, the graph goes up forever, it never stops, so a positive infinity. I shouldn't have drawn that vertical line there.
I'll do it like this.
There. I'm not even going to do it. That looks better. So, it's the y-coordinate
You could have said F.
of vertex, comma, infinity. Now, if it's opening downward, let's apply that same logic. There's the vertex. The vertex is at the ordered pair 1, 2. Is this vertex a maximum or a minimum? A maximum. Okay, what's the maximum y value? What's the biggest y value on that graph? It's that 2. So you would say the range. Remember, interval notation has to go small to big. So it's negative infinity up to 2. Parentheses, negative infinity up to 2. So when a parabola is opening downward, you expect the range to be in the form negative infinity, comma, whatever that y-coordinate is there, the y-coordinate of the vertex, y-coordinate of vertex. And at the y-coordinate we use a bracket because that number is being used. It's being used right there at the vertex. Oh, wow, that looks bad, doesn't it?
It does. But some good, pretty red would make it look better.
I know it would, but then people can't see red.
No, I'm just trying to... Well, why is that line even important?
I don't know. It's not important. You're right.
If you use the
So, that erasable ink, that's so hard to read. Let's do number 9.
Yeah.
I think we've talked long enough.
Okay, I think we're getting timed out. Way more. I knew that was going to happen.
We're going to start at number 9. We'll go back. Don't worry about the earlier problems. As I said, we're doing quadratic functions first, then we'll go back. They give us the quadratic function. F of x equals 3x squared plus 30x plus 72. Wow. They want us to find the vertex, axis, domain, and range, and draw the graph. So I think I'll write out the information they want. Vertex, axis, domain, and range.
One of these we can fill in right now.
You're right. One of these blanks I'm going to write in the answer right now. Which one? All quadratic functions have the same blank. Not range, domain. Okay. The domain is all real numbers.
Negative infinity, common.
Okay. The domain is all real numbers. Let's determine the vertex. To determine, well, I already, just looking at this function, by the way, the problem's at f of x, and I wrote y. Remember, f of x and y are interchangeable, so I was just feeling lazy, I wrote y. Look at that a value. A is positive. When I draw this graph, do I expect the parabola to open up, or do I expect it to open down? Which one? It's going to open upward. Remember, 2 pages back I said, if the leading coefficient is positive, you expect your graph to open up. So I'm going to make a little note. When I draw this thing, I expect it to look like that. Let's use our vertex formula. X equals negative b over 2a. Now, realize A, B, and C are just like with the quadratic formula. C would be 72, which we don't use, okay? A is 3, B is 30. So we have X equals negative, what did I say B was? 30, the number in front of X, all over 2 times A. We can do that in our head. 2 times A, what's A? So 2 times 3 is 6 to give me x equals negative 5. That means the graph is going to have a vertex at the point where its x value is negative 5. That's not saying that vertex is negative 5. The vertex is an ordered pair. But what you found here, you found the axis, that imaginary vertical line passing through the vertex. And it's in the form x equals negative 5. And they're probably going to tell you, type an equation. If you just type negative 5, they'll probably count it wrong. I think one of the times they give you the x equal, and another time they don't. But the axis is a vertical line, and it has to be in the form x equals negative 5. Now I'm going to make a table of values. Oh, as I was going through what we were graphing, okay, you'll click the graphing tool. You have to label the vertex. And how do we find the vertex? We find negative b over 2a. We did that. And now we're going to plug it in to get the y coordinate. When x is negative 5, what will y be? No. When x is negative 5, we're going to have to plug in negative 5 there.
I'm going to use
we have y equals 3 times negative 5 squared plus 30 times negative 5. I think this is one I can do pretty quickly, but you use your calculator and we'll see if we get the same thing, Tony. Remember, you perform the exponentiation first. Negative 5 times negative 5 is positive 25 times 3. That's a 75. That's a minus 150. 75 minus 150 gives me a negative 75. Negative 75 plus 72 gives me a y value of negative 3. Tony, what did that calculator of yours say?
This newfangled calculator gave me a negative 3.
Them newfangled things, I tell you, what are they going to come up with next?
I hear you can take your phone with you now. when you leave your house.
Where you hear that? Got to have a long wire, I guess.
Oh, wow. I
Okay.
sort of wish I didn't do that.
And it's recorded.
It's recorded.
Okay. Okay.
Well, anyway, -3.
Okay. Negative
Oh,
3.
go ahead and fill up the vertex line.
So we now know the vertex. It's the ordered pair -5, -3.
Make sure you put it in parentheses when you type it in, as you'll see in a little bit. Why don't we go ahead and...
Let's draw the... Well, no, we need another point. Remember, we said we have to have the vertex, and we need another point. Y'all tell me, what's my favorite number to plug in? 0. Don't do this. But if we plug in 0 here and here, what are we going to get for y? Do you think they're going to have 72 little spots for us to go up? No. You're going to have to choose an x value that's real close to the vertex. My advice to you is don't move more than 2 units away, or else you're going to get a y value that won't fit on your graph. You could use like a -6 or -7, or you could use a -4 or a -3. What do y'all want to use? I couldn't hear you. -3? Okay, that's what I was thinking. Let's plug in -3.
Oh, I thought you said -6.
Oh, did you say -6?
Oh, okay.
I'm not the only one that's half deaf, Tony. So we're plugging in -3 to see, and I bet you we'll get a number that'll fit on the grid. Tony, are you punching it into the calculator?
Mm-hmm.
Okay, and that is going to give us a...
Oh, you haven't done it?
Okay, that's a 27 plus 90. 27 plus 90.
Oh.
90.
Wait. No, a -3.
Oh, it's a -3, thank you. So that's a plus a -90. That'll be a -63 plus 72. Am I doing that right? Is it a -63 plus 72, so I'm getting a positive 9?
I would have added the 2 positive numbers and subtracted 90 to get a 9.
So 99 minus 9, that'll still give us a, what did I say, 9? So here are the 2 points. We'll use the vertex and 1 additional point. Let's go to the homework before we get timed out. Oh, you need to type in the vertex, and it's an ordered pair, parentheses, -5, comma, -3.
-3 or positive 3?
-3.
-3, okay. Close the parentheses.
And then,
I think
now
when
we're
they
going to
say
graph.
it. Push them. What happened? Oh, there it is.
Move your calculator.
Mm-hmm.
Click to blow up.
Oh.
And whether your parabola is going to open upward or downward, you use the same vertical parabola graphing tool. Stop right there. Notice it says vertical parabola. The one beside it, y'all see what the one beside it is? It's a horizontal parabola. Are we going to be graphing those? No, because they're not functional.
They're to trick you. Every day when I drive to work, I drive past streets. I've never been down there. They're just there to trick me and make me see, am I going to turn that way? That's not really why they're there. But
now we plot the vertex of -5, -3. And remember, you look at the yellow box up at top to be able to see -5, -3.
-5, -2, negative.
There it is.
Oh, no.
Nope.
Oh, God.
Click.
No.
Now, I thought you had it.
No. What?
Clear it.
Oh, okay. Let me try again. -5, -3. There, I did.
Now move your mouse around to show them. As you move around, it's drawing every possible parabola with a vertex at -5, -3. Now it wants us to plot. Stop that. Okay. Now it wants us to plot the secondary point, the one that we found, -3, 9. You could have plugged in -4, you would have gotten a point on the graph. You could have plugged in 6 would have gotten a point, but we plugged in -3.
If we had
got
plugged
9.
in 0, we'd have to go up 72 units. You see, it wouldn't have fit on
Be
there.
way up here. Okay. Check.
Yeah.
And we're still not through. Now we got to type in, okay, they want the axis.
Show your spot that you wrote it.
No, okay. X equals, that little vertex formula is the axis formula. X equals, that means it's a vertical line, -5. So type in X equals -5. The domain, we know the
We knew that
domain.
immediately. Okay, so parentheses, negative, infinity. Wouldn't it be nice if there was just one little button you clicked? Oops,
Oh, what did he do?
I hit the wrong.
You should never have to click more. Okay? If you're trying to type something and it's not showing down there on the main toolbar, then you're trying to type something you don't need to be typing.
Now, here's the
range. Now, let's go back and look at my paper, my little cheat sheet I made for y'all with regard to ranges. Okay? The range is the thing that people always seem to have trouble with. The range, if it's opening upward, that y coordinate is a maximum. So, a minimum. If it's opening downward, it's a maximum. So, if it's a minimum, remember, interval notation goes small to big. If you know that number is the minimum, then it's that number to positive infinity. If it's a maximum, that means the vertex y coordinate is the biggest y value, so small to big would be negative infinity up to that y coordinate. Which case do we have, A or B? A, so it's going to be the y coordinate of the vertex up to infinity.
Just showing your fork, and I've zoomed away from that, trying to show the graph. Just make it a little bit big enough so they can tell.
The y coordinate is at -3, and that's the smallest y coordinate on the graph. And interval notation goes small to big, so -3 to positive infinity. But you have to use a bracket because -3 is used. You could label a point right there at -5, -3, where the vertex is.
-3, infinity.
For the range, you use the y coordinates. That makes sense. The range is the y coordinates, so you don't use the x coordinate.
Write that down.
Oh, let me write this down. Let me switch over.
He's just
So we said that the range was bracket -3 to infinity.
A student asked me once, when you look at the vertex, is it true to say that the x value of the vertex will always be in the axis and the y value will always be in the range? That's what she asked, and what was my answer? Yes, that's true. Okay? Let's do number 8. Oh, wow, Tim, we've been going 28 minutes and 30 seconds. You've done one problem.
Mm-hmm.
I think that's that.
Remember the little caricature for Zelda? Oh, we've been going 45 minutes and we've only done 3 problems.
I think it was this stuff right here.
Mm-hmm. So y equals x squared plus 12x plus 32. They're asking for the same thing here. We'll need the vertex.
Oh, I guess.
Axis. Domain.
Oh, we should have done 7 instead.
You want to? I can do that. What's 7?
Do you mind if we change it to number 7? Because number 9 opened up, and number 8 opens up.
How does number 7? Look at number 7. What's that a value in front of x squared? Negative, so how's it going to open? Let's do number 7 instead. Good thinking.
Just move to another sheet. Oh.
Yeah, you're right. I'll just go to another sheet of paper.
I'm sorry about that.
Y equals a negative x squared plus 6x minus 12. And we want to find the vertex, axis, domain, range.
This is one of those problems in the old editions. It had like through 8 parts. It kept asking more and more questions. And that was one of those things I remember.
You telling them?
You have too many parts for one question. And they changed it. They listened to you.
Mm-hmm.
Or someone else said it. And
Yeah.
Okay.
Okay. I can fill in one of these blanks. Which one? Vertex, axis, domain, or range? Domain is all real numbers. Let's find our vertex. X equals negative b over 2a.
And when you're finding the vertex, you're also finding what? Don't say ax.
Oh, the axis. Okay, there. What am I going to write here? What's b? So we have negative 6. Oh, that doesn't look like a 6. Does that look like a 6?
That's consistent.
It looks sort of like it. And what's a? Negative 1. 2 times negative 1. What do I have down here? Negative 2. Negative 6 divided by negative 2. What am I getting for my axis? X equals positive 3. X equals positive 3.
There's like 3 comma back here.
And that means the vertex occurs at an ordered pair where x is 3. Negative 6 all over 2 times negative 1 is negative 2. Negative 6 divided by negative 2 gives me a positive 3. What do we do to find that y coordinate? Plug in, I agree.
You're going to make a little bitty XY table.
We got to plug in 3. Plugging in 3 for x. 3 squared is 9. Are we going to square that negative there? If I wanted that negative squared, what would I have had to do?
And I can't imagine. Yeah.
Enclose in parentheses. So you perform the exponentiation. 3 squared is 9, and then that gives us a negative 9.
So, please excuse me.
Plus 6 times 3, that's a plus 18 minus 12. Negative 9 plus 18 is 9 minus 12. I'm getting a negative 3. It's just a coincidence that the y coordinate of the vertex is another negative 3. That will not always be the case.
Is that what it was on the other?
Mm-hmm.
Oh, wow. Negative 3.
So I write my negative 3 right here. Y'all follow what I did? I plugged in 3 and simplified to get the y value of negative 3. Well, my favorite number to plug in is 0. You think I can use 0? If I use 0, what am I going to get? 0, 0, negative 12. I think it only goes to 10, though. I think if we use 0, that we're not going to...
Well, let's just go ahead. Let me type in.
Okay. Type in that vertex and see how big the graph is.
Sure to put the parentheses.
3, comma, negative 3.
Close parentheses. And let's look now. You can use 0.
We could use 0. Look at that. Look how far. Y'all want to use 0? And that gives us a y value of negative 12. So we have to plot our vertex. And then the secondary point.
Little parentheses around there. Okay.
So you plot those
Okay,
are
so
very sloppy parentheses too.
Okay, so let me pop this out. Vertical parabola.
Whether it opens upward or downward, there's only one vertical parabola tool. 3, negative 3.
3. Am I 3, negative 3?
Yes. And then the secondary point is 0, negative 12.
Am I at 0, negative 12?
Yes, you are. Save it. Check answer. And the axis. We know the axis. Type an equation. It's x equals 3. The axis uses the x coordinate of the vertex. The domain we know is negative infinity to positive infinity. And now the range. Let's see. Is my vertex a maximum or a minimum? It's a maximum. It's the highest point on the graph. So here's my logic.
Oh, let me show what you're drawing.
Put that away. That's a 3, negative 3. The vertex is a maximum, so that negative 3 is the biggest y value there is. That's the biggest y value. It goes small to big, so 3 has to be to the right. Since that's the biggest thing, what do you put in front of it? Negative infinity. That's what my logic that I was using just now is what I was trying to show y'all earlier in the previous problem. If it's the maximum, that means it's the biggest. When you're writing interval notation, small to big, the biggest has to be on the right, so on the left you have negative infinity. Over here, let's see, it was opening upward, so that's the smallest y value. That y value was also negative 3, wasn't it? That's the smallest y value. When you're using interval notation, it goes small to big, so the negative 3 goes on the left, and the positive infinity goes on the right. I'm doing a very poor job of explaining how I remember.
Consistent.
It is consistent. You're right. I don't know what movie you got that line from. I do know, okay, from my childhood. Is that clear? And the person's like, no, but it's consistent.
It was a movie we watched as a child and years later I got to say it. I never disliked teachers. There was one teacher in graduate school that I just couldn't,
Really?
And one day he asked, is that clear? And I said, I know I was speaking for the class. I said, no, but it's consistent. He already didn't like me, so what the heck.
I thought it was negative 3.
It is negative 3. Tim,
It
look
is
at what
negative
you've done.
3.
Oh my gosh.
Oh, thank you. Negative 3. Thank you.
And right here, no, that's right.
That's right.
3.
That's positive 3.
Okay.
The x is positive 3. The y value is negative 3. Is this when I say, if in doubt, just type negative 3?
Yeah, that's it. So parentheses, negative infinity, comma, negative 3, bracket.
Don't say it. Don't. When you see, it's the maximum. That's the maximum value. So the negative 3 has to be on the right. When the vertex is a minimum, negative 3 has to be on the left because interval notation goes small to big. To me, it's crystal clear, but I think I'm doing a bad job explaining my logic for those ranges. Any questions there? Number 11.
Now I'm going to say, if in doubt,
Use the vertex
do
formula.
the minus b over 2a and plug it in, and that'll get you the answer.
A woman has a taco stand. She found that her daily costs are approximated by C of x equals, this is number 11,
Oh.
C of x is equal to x squared minus 20x plus 680, where C of x is the cost in dollars to sell x units of tacos. So let me make sure that miscopy this. X squared, okay. Find the number of units of tacos she should sell to minimize her cost. What is the minimum cost? I don't know what a unit of tacos is. Maybe a unit is a dozen, okay?
Or maybe it's just one.
Or maybe it's just one,
Or
okay?
2 or 3, or I don't know.
Or 10, I don't know. It doesn't matter. We want to find the number of units of tacos that she has to sell to minimize her costs. She wants to spend the least amount of money possible to run her taco stand. Switch to my paper. They don't ask us to draw a graph of this function, but if they did, looking at that first term, do you expect the parabola to open upward, or would you expect it to open downward? You would expect it to open how? Upward, I agree, because the A value is positive. If the parabola is opening upward, what have we got, a maximum or a minimum? A minimum, and where does that minimum occur? At the vertex. So, aren't they asking for a minimum? She better be asking for a minimum, because there's not a maximum. You see, it keeps going up. And it's opening upward, there's a minimum but no maximum. Is that what the problem asks for, minimum?
Minimum.
Mm-hmm. Yes, it is. So we use our vertex formula. X equals negative b over 2a. What's b? That negative b, that's a negative 20 all over, what's a? What's the 1? 2 times 1, what have we got down here? 2. The opposite of negative 20. That became a positive 20 divided by 2. What are we getting as our x value? 10. Does that mean her costs are $10? Is that what we found? What was x representing? Was it representing dollars? No, the cost is in dollars. X is the number of tacos. So she should sell 10 units of tacos if she wants to minimize her daily costs.
I suspect it's not just one taco.
I figure it is, and it's probably a dozen or something. So 10 dozen, but whatever a unit is. Okay. How do we find the cost, though? Once you know the x-coordinate of the vertex, how do you find the y-coordinate? Plug it in. The cost, when you plug in, not 20, it's 10. When you plug in 10, the cost when you plug in 10, that's 10 square minus 20 times 10 plus 680. I can do this in my head. That's 100 minus 200. That's a negative 100. Her minimum costs are $580.
So it's definitely not just one taco is a unit, because if it's costing her $580 to make 10 tacos,
that would be $58 a taco that she needs to sell it for just to break even. Okay, so a unit is maybe a dozen, maybe it's like 100.
Yeah, maybe it's a gross.
Mm-hmm. Number 12.
Oh, wait.
Wait.
Questions?
Go back to my work.
Oh.
Any questions here? Down here. These word problems will be asking for maximum or minimum values. If you're looking at a quadratic function, the maximum or minimum must occur at the, starts with a V, vertex. Okay. Number 12.
This is the mosquito problem.
This is it, Tony. I'm buying myself some good
I'm going to buy some pins.
The 1.0 ones, okay, like this. The number of mosquitoes, M of X in millions, in a certain area depends on the June rainfall, X in inches. The function that models that phenomenon is M of X equals 26X minus X squared. The number of million mosquitoes is equal to 26X minus X squared, where X is the June rainfall in inches. Let's all agree that if we got a whole lot of rain by some miracle and there were a lot of mosquitoes, no one's going to complain, right? I'm guilty of complaining when it would, back in the olden days when it used to rain a lot and we'd get mosquitoes, I'd complain about it. I promise you I will not complain, okay? But X is the number of inches of rain. There's something, okay, let's switch over. We have to be careful. Is this parabola going to open upward or downward? What is the A value? Be careful.
Okay.
It's going to open downward. Just because the X term is first, the A value is negative 1.
Write that in standard form.
I'm going to write it like that. The A value is negative 1. What's B? The 26. Okay. B is the number in front of just X. A is the number in front of X squared. That's a negative 1. That means we expect our parabola to open downward. If it's opening downward, what have we got? A maximum or a minimum? A maximum. The maximum is occurring at the vertex. So we use our vertex formula. X equals negative B over 2A. So we have a negative what on top? Negative 26 all over 2 times A. 2 times negative 1 gives me A. Negative 2. Negative 26 divided by negative 2 gives me positive 13. Is that 13 million mosquitoes? What is X representing? The rain. So if there's 13 inches of rain, then the number of mosquitoes are maximized. So we come over here and we type in 13.
Price of the peanuts has gone up from 11 to double.
Okay.
But we got to buy them.
1 pesos. Now, how do we find the maximum number? How do we find that number of mosquitoes? Once you know the X coordinate of the vertex, what do you do to find the Y coordinate? Plug it in. So we got to plug in 13. Switching to my paper. Switching to my paper, I will go to my function and plug in 13 for X. 26 times 13 minus 13 squared. Is that going to give me 169? I'm getting 169 million mosquitoes. Mm-hmm. Am I right?
Yep.
Yeah. Okay. But I did 13 squared is 13 times 13. This thing is 26 is 2 times 13. So I had 113 times 13 remaining. And that's how I got that 169 million mosquitoes. Did you type it in? I used to make a joke at this point, back when it used to rain, I would joke, so if there were 14 inches of rain, they're saying there'd be fewer mosquitoes. What happens to those mosquitoes? Do they drown or what? Why is it that 14 inches of rain, there'd be fewer mosquitoes? I was always taught as a child that the more it rained down here, the more, in a warm climate, the more mosquitoes there were. But I'm not complaining about mosquitoes. All I want is rain. Lots and lots of rain. So, any questions there? Look at what we did. We first of all analyzed the function and realized that A and B, we had to be careful selecting the values of A and B. We determined that there would be a maximum and that would occur at the vertex. We used our vertex / axis formula to find the X value of the vertex, and then we plugged in that X value to find the value of the function. Number 13. If an object is projected upward from ground level with an initial velocity of 96 feet per second, then its height in feet after t seconds is given by s of t equals negative 16t squared plus 96 times t. So t is the number of seconds. The object is being projected upward, and t is the number of seconds. A function of this format is called a position function, and it's standard practice to use the letter S to represent position. You might think, why aren't they using a P or something? I don't know. It's physics notation. They use an S, so we use an S also.
Future physicists in here, do you know why they're using S? If so, just call it out.
No.
If not, well, you'll learn in your physics classes maybe.
What letter is acting like X here? T. So instead of X equals minus B over 2A, minus B over 2A, we'll use a T. Would we expect this parabola to be opening upward or downward? They don't ask us to draw the graph, but I still like to think about that. It's going to open downward because that A value is negative. If it's opening downward, do we have a maximum or a minimum? A maximum, and that's what they asked for. They better have asked for a maximum because the parabola opening downward, that's what we can find. Instead of using the vertex x equals minus b over 2a, we'll use t equals minus b over 2a. So we have a negative. What number's up here on top? The 96. 2 times a. 2 times what? 2 times negative 16 gives me a negative 32. Oh, this is nice. Normally this does not happen. Normally we'd wind up converting to decimals. But negative 96 divided by negative 32, what's that giving me? Isn't that just a positive 3?
And right now I should mention...
Be prepared when you're doing it in your homework. You'll probably be getting something like 2.5 or 2.75. It'll be a second, it'll be a decimal. In most cases, a decimal that terminates, okay? You might wind up with 4 or 2. It might go in evenly, but most of the time, it always winds up being something other than a flat integer.
We should mention right now...
Is that saying it's going up 3 feet? What is that 3 representing? The seconds. So that object goes up for 3 seconds, it reaches a high point, and then what does it do? It doesn't just sit up in the air. What does it start to do? It falls back down. So 3 is seconds. Tony, what were you saying?
I've been trying to say it throughout all of these. Should you expect negative answers? Like if you've got your number 12, would it make sense for you to have a negative 13 inches or a negative 3 seconds?
Would that be sensible? No, it wouldn't.
So you make sure your answers for these word problems are positive
sensible.
numbers.
Or sensible answers, which means they need to be positive. So the object will take 3 seconds to reach that maximum height. Switch back to my paper. Now what do we do to find that maximum height? Plug it in. The height after 3 seconds is negative 16 times 3 squared plus 96 times 3. And Tony, you have your calculator going?
Negative 16 times 3 squared is 9 plus 96 times 3... 144.
144 feet. So this object went up for 3 seconds. It reached a height of 144 feet, then it fell back to Earth.
So 144 feet. Any future physicists are going to recognize that negative 16 t squared.
That's a result of the acceleration due to gravity. If we didn't have gravity, look back at that function. 96, that's the velocity, the rate at which the projectile is being thrown up into the air. That's rate times time. Distance equals rate times time, so that second term, 96 times t, that's just rate times time. And that's what would happen. If we didn't have gravity, it would just go up and keep on going up. But that negative 16t squared, that's gravity trying to pull the object back to
Just
Earth.
trying to, but in this case, successfully doing it. It pulled it down.
Okay. Any questions?
I've already punched in the answer?
Punch in 144? Yes, you did.
I've already got the check. Okay.
Any questions? We're through with the first half of the class. Now we're ready for the second half with the piecewise functions. So if there's no questions left on parabolas, we'll now switch on to piecewise functions.
Oh.
Switch to my paper.
Oh.
No, I need to write
I wanted them to see what you mean. A piecewise function is broken up into pieces. So go ahead and write a little, Tim.
A piecewise function
I need to calculate it anymore.
is a function defined by two or more algebraic rules. It is defined using two or more, I would say defined using two or more pieces, but I hate to define piecewise using the word piece. That's a bad practice. So I'll say it's defined using two or more algebraic rules. We're going to do two things with these piecewise functions. We're going to
Plug into them?
We're going to plug in and evaluate. The formal word is evaluate, and then we're going to graph them. The evaluation is simple once you understand how to read the functions. First of all, we're going to say evaluating piecewise functions. For example, which one is it, 2? Looking at number 2, they give us a piecewise function that uses 3 pieces. We have h of x equals, and there are 3 pieces. We'll use the piece negative 4x minus 16 for x values that are less than negative 5. We'll use the piece do you have a green one? We'll use the piece 5 for x values between positive 5 and negative 5 inclusive. And we'll use the piece x plus 4 for x values greater than or equal to 5. I had a better black pen earlier. What happened to it? No. Okay. They ask us to find h of negative 7. Let me write down.
While he's writing down, let's review that definition of function that we saw on Monday. For every x, there can only be how many y values?
For each individual x, there can be only one y value. So if I plug in negative 7 in this function, and I get 4, and you get 3, one of us is wrong. You can't plug that negative 7. You can't say, I'm going to just plug it in everywhere there's an x. You have to decide which piece you're going to use. The number in the parentheses. The number in the parentheses, keep in mind, that's the x value. h of negative 7. Is negative 7 less than negative 5? Or is negative 7 between negative 5 and positive 5? Or is negative 7 bigger than positive 5? You have to decide which piece you're using, and you can only use one. Which inequality is satisfied by negative 7? The first, second, or third?
Wait, the first.
The first, negative 7 is smaller than negative 5. So, we're going to plug the negative 7 into the first piece. Negative 4 times negative 7. That gives us a 28. 28 minus 16 gives me a y value of 12. H of negative 7 is 12. What about H of 2? Before you have to decide which piece you're going to use. You can only use one of them. Is 2 smaller than negative 5?
When you say smaller, you mean to the left of negative 5 on the number line.
Or is 2 between negative 5 and positive 5? Or is 2 bigger than positive 5? It's between, so we come over here. Hey, there's no variable to plug in. This middle part is constant. For any number between negative 5 and positive 5, the y value is going to be just 5. So H of 2 is 5.
You know what? I'll type them all in.
What about H of 5? Is 5 less than negative 5? I guess the real question is, which of these, I miscopied the problem.
Oh,
Do y'all see what I've done? I haven't allowed this part.
That's,
This should just be, that is just a less than. The equality possibility is here. Greater than or equal to. Do y'all see how I knew I miscopied? Because I had two inequalities being satisfied by 5. There can only be one inequality that satisfies, that allows x to equal 5. Which one allows x to equal 5? The pink one or the black one? That black one. That's just a less than. So we have to use 5. The black piece, we plug in the 5. We're going to get a 5 plus 4, which gives me a y value of 9. Here's one.
Oh, maybe this one. Yeah, that's the one I found.
Last piece, the last question. H of 8. X is 8. Is 8 less than negative 5? Is 8 between negative 5 and positive 5? Or is 8 greater than 5? Which inequality is satisfied? The third one, so you plug into the third part. 8 plus 4.
5 plus. Oh, yeah, 8.
8
right.
plus 4 gives me 12. Go ahead and type in those answers so we don't get timed out, Tony.
So this one's 5.
5.
And then
9.
9.
Click in the box.
9.
And finally
12.
And let's switch back to my paper.
Let's do a few more of those.
We're going to do a few more working with this problem here. Working with this problem out here. Let's say H of 0. What's H of 0? Which piece are we going to use for H of 0? First, second, or third? The second. 0 is between negative 5 and positive 5. So the y coordinate is just that 5. There's no variable to plug into.
H of negative 100.
What about, okay, that's a good one. H of negative 100. H of negative 100. Which piece are we going to use? First, second, or third? What's my x value? Negative 100, is negative 100 less than negative 5? Is it between negative 5 and positive 5? Or is it greater than positive 5? It's less than negative 5, so we have a negative 4 times a negative 100 minus 16. That's 400 minus 16. Is that 384? Okay, I have another one. H of 4.9999. H of 4.9999. Which piece will we use? First, second, or third? Second, 4.9999 is between negative 5 and positive 5. So, what's the y coordinate in that event? Just a 5? That means this point is on the graph. We're going to start graphing these things in a moment. This point has to be shown on that graph. When you're drawing the graph, what would it look like to the naked eye? To the naked eye, if you plotted that ordered pair, 4.9999, comma 5. If I told you, come up here and point at that on an XY grid, to the naked eye, what would it look like? It would look like it's 5, 5, wouldn't it? But we've already said that X can't be 5 in the pink thing. But here are points that look just like 5, 5. And we're going to have to take that into account. We have a real nice way of handling that. I have another one. Now, I guess that's enough. Let's just go on. Any questions? To evaluate piecewise functions, you have to figure out which inequality is satisfied based on the X value, and then plug into the appropriate part. So evaluating isn't the bad part, isn't rigorous. Graphing, well, that takes a little thought. To graph piecewise functions, we're going to plot points. We're not going to do anything real fancy. We're going to plot points. But we're going to plot points intelligently. We're not just going to start randomly. Here they were just sort of randomly choosing X values to have you evaluate the function. We're going to plot our points to graph these things, but we're going to plot them intelligently. So, graphing piecewise functions. And when graphing piecewise functions, this is the thing that where it just works out so much smoother if I have different colors for each piece. So if I'm going to be using some different colors here, and if you can't read it, yell it out to me, okay? If you have trouble focusing on it, that's what happens. People color blindness, and the people aren't really blind. I have trouble reading stuff on colored paper. If the print is on colored paper, that's why I quit reading graphic novels.
Older and older and older as you've gotten older.
Yes, but I first noticed it in 2004. So you're talking 22 years ago was the first time.
You were 40. That's
oh wow, I was old, even back then. Thanks. Okay.
Now, which one are we graphing?
I don't know. Number
problem
6. We're gonna.
A really good example for the first graphing.
Well, there's no graphing tool for piecewise functions. So those of you that like the multiple choice format better, then you're lucky here. These things we're going to graph them on paper, and then we'll just pick the graph that looks like the graph we drew. Okay? This is number 6. To illustrate how we're going to graph these.
So you're going to write the first piece. He's going to put a different color for each piece.
That's right.
I've ordered more pens.
A day late and $1 short, don't you think? 2 plus 2x is the piece we'll use if x is less than negative 4. I like them to say if rather than far, or just a comma. I prefer just a comma, x less than negative 4. We'll use the piece. I'm going to do this one in green, negative 2x if x is less than or equal to negative 4, is less than or equal to 5, and
X is greater than or equal to negative 4 less.
oh yeah, you're right. If x is between negative 4 and positive 5 inclusive,
Y'all see
the
how
last
he reads
piece,
that? If you have two less thans or two greater thans in the same statement, just start with the middle and say between. Negative 2x if x is between negative 4 and 5. Then you know what it means. If you look at negative 4 less than or equal to x less than or equal to 5, you might be like, what the heck is that saying?
that's saying your x value is between negative 4 and positive 5. So if x were 7, would you use that green piece? No, 7 isn't between negative 4 and positive 5. We have one other piece I haven't written down. I'll write this in my black ink, 2x if x is greater than 5. Okay, we have three separate pieces. Y equals 2 plus 2x. Y equals negative 2x. Y equals 2x. All of those expressions are what? If you were to graph one individual piece, what sort of a figure would you expect to get? Do you expect to get a parabola? If it's a parabola, you have to have what on the x? A square? It's not parabola. What would those pieces be? They are all
Starts with L.
linear. How many ordered pairs do you need to draw a line? The minimum number. 2. 3 is good practice, but you only need 2, okay? So we're going to find 2 points. But as I said, we're going to plot points, but we're doing it intelligently. We'll start off with the blue piece. Oh, I'm going to number these pieces. This will be piece 1, 2, and 3. I'm going to make 3 tables of values. Piece 1, I'm making a table of values. Here's something that you may be shocked by. The first number or numbers that you must plug in. Oh, by the way, for lack of there's no word for these numbers here. They're just the numbers and the intervals. The inequalities. For lack of a better word, I'm going to call them my cut points. We have cut points at negative 4 and positive 5. That's where the inequalities cut off. At negative 4, blue changes to green at negative 4. Green changes to red at positive, black, at positive 5. You must start off by plugging in your cut point. Even if there's no equality, you've got to plug in that number into the piece. That'll take care of things like this point right here that looks like a point on the graph, but really isn't. We'll discuss that more in a moment. But the first number you must plug in is any number that appears within the inequality. Then you need another x value, one that's actually less than negative 4. And so be thinking about what you're going to use. Now, for this first point, that cut point in negative 4, to label the cut points on the grid, we're going to use the same rule we use for solution cut points. X can actually equal negative 4, so we're going to label this ordered pair with an open circle. We need another x value, something that's less than negative 4. Could I use 0? No, I need a number smaller than negative 4. How about to the left of negative 4? How about negative 5? Is negative 5 to the left of negative 4? Now, the secondary numbers that you choose on your own are just regular closed dots. The only time you can have an open circle is when you're plugging in a cut point for which there's no equality. This last piece, we're going to have to plug in 5 for x. But there's no horizontal bar there, so we'll have an open circle on that third piece also. What about when we use negative 4 and positive 5 here? Are we going to have open circles on the middle piece? because the equality is allowed. Plugging in -4, we're going to get into the blue piece. 2 plus -8, that gives us a 2 plus -8,
2 times -4 is -8.
which gives us a y value of -6. What are we going to get when we plug in -5? You'll have a 2 plus 2 times -5 is -10. So you have 2 plus -10. That gives you a y value of -8. We plugged -4 and +5 into the blue piece, that first piece. Now I'm going to draw an XY grid. It's a big XY grid because think about it. When you start plugging in 5 and a number bigger than 5 down here, you're going to be getting what? 10 and 12?
I think last semester we did it over here and it worked really well like that.
I think that's a good idea.
Yeah.
Okay,
So I
let's
just
do that.
remember it because
I'm going to make a nice big XY grid. This is a big graph. Okay, there. Okay, there.
Why don't you go ahead and label those cut points right now on the x-axis?
What the cut points where the blue piece changes to the green piece and the green piece changes to the black piece. That occurs at -4, 1, 2, 3. Here's -4. And +5. 1, 2, 3, 4, 5. Oh no. Now we'll have 6 over here somewhere. We have the ordered pair, -4, -6. That's a open circle. That's our starting point. 1, 2, 3, 4, 5, right. Oops, I lost my place. So that would be right there. -4, -6 has an open circle. The numbers that you choose on your own are just regular closed dots. So at -5, -8, there's -5. We go down 2 more units. At -5, -8, we have a plain closed dot. The graph starts at the cut point. It can't go past the cut point. It starts at the cut point and it goes to the left. Does it stop? All the numbers, the x-axis less than -4. Does that stop? It starts here and starts going. Does it stop? No. So there are arrowheads on the left side, that bottom left side of the graph. It just keeps going and going forever. Now the second piece. This will be the green piece, piece number 2.
And it's going to be between -4 and +5.
Any numbers that appear in the inequality, you have to plug those in for x. So you have to use -4, you have to use +5, and you don't have to choose another value on your own. There's no free will here. You already know. You got to use -4, you got to use +5. Plug in -4 into that middle piece. -2 times -4, -2 times -4. What is that giving me for y? +8. Plugging in +5. -2 times 5. Giving me a -10. Realize equality is allowed on that middle piece. So we're not going to have any closed circles. Those will just be, open circles. We're just going to have regular closed dots. You only have an open circle when you're plugging in a cut point for which there's no equality. So at -4, positive 8, left 4, up 8. Oh, Lord. 1, 2, 3, 4, 5, 6, 7, 8. So right out there we have a closed dot. And then 5, negative 10. Right 5, down 10s. Now, if we plugged in a 0, we'd get 0. So the graph is going to pass right through that origin. That'll help me draw this line a little straighter if I focus on that origin.
Miss it. Oh, no, that's pretty good. Just make the dot bigger.
Yeah, if you miss it, I remember that from high school. If your graph misses your dot, you just make the dot bigger. And notice something. Here's my question. Where are the arrowheads? Do we have any arrowheads? If so, are they on the left or on the right or both?
Or neither. Or no. Neither.
The interval doesn't keep going and going forever. These intervals that have two numbers appearing, that's saying it starts at negative 4, it stops at positive 5. The arrow, it doesn't keep going up, it doesn't keep going down.
Usually in graphs, where do the arrows occur? Do they occur in the middle of the graph? Or do they occur on the ends? Say the ends, that was a bad question, but notice on the left side.
There's no such thing as bad questions, Tony. Only bad teachers asking those questions. Yes, okay. Asking those bad questions. Okay. Where's my black pen? I found a black pen. Here. Finding part number 3. Table number 3.
If you get the hang of this, you understand graphic a lot.
Yeah.
Wow.
Okay. What's the first number we have to plug in for X? You have to plug in 5. But equality isn't allowed here, so you label it with
open or closed? Open.
Open. Now we need another X value, a number bigger than 6. Bigger than 5. What do y'all want to use? 6? Now, is this going to be an open circle? Is 6 bigger than 5? Yes. The numbers you choose on your own cannot be open circles. You have to choose numbers that satisfy the inequality. And so the numbers you're choosing on your own have to be regular closed dots. Well, plugging 5 into that third piece, what are we getting? 10. Plugging in 6, what are we getting? 12. So we go right 5 up 10. There's 10. We have an open dot. And then 6. Here's 6. We go up 12. Is that 12? That looks like 12, right? The graph always starts at the cut point. Here's something I don't think I've ever said, but it's true. You start at the cut point. The graph can't keep going past the cut point, okay? It starts there and goes towards the remaining point. That X greater than 5. Does that interval ever stop?
It's just 5, 6, 7, 8, 9, 10.
It keeps going forever. So the right side has an arrowhead. You can't have arrowheads just appearing randomly throughout the graph. There's only 2 places you can have an arrowhead. On the far left, that's what we have here, and on the far right, that's what we have there.
That's what I was trying to say earlier.
Okay.
I did such a poor job at it.
Now, here's my question. Suppose we're looking at this third piece, 5.00000001. How many zeros is that? 1, 2, 3, 4, 5, 6. Do you all agree that that satisfies the inequality? It's bigger than 5. Just barely, but it's bigger. That means we can plug that in 2 times 5 gives us a 10.0000. That was 6. 1, 2, 3, 4, 5.
And a 2.
This point has to be shown on the graph. That ordered pair must be on the graph. Well, let's see. If I were going to graph that point, what would it look like to the naked eye? I'm going to come over here, and so it's
Plot this point.
yeah, it's a little bit to the right of 5, a tiny, tiny bit.
So small.
I go up. It's just a little bit bigger than 10 to the naked eye. What does this point look like? It looks like 510. That's why you have to plug in that 5. Even though 510 isn't on the graph, there are infinitely many ordered pairs that to the naked eye look like 510 that are on the graph. Real numbers are dense. I could just keep on, stick on another 0, stick on another 0. There's so many points that look like 510 that are on the graph. So this ordered pair is saying 510 itself isn't on the graph, but there are other points right there that look like 510 that are on the graph. Likewise, this open circle here, -4, -6 are not on the graph, but there are plenty of points right there that to the naked eye look like -4, -6 that are on the graph. That's why you have to plug in that starting value when you're drawing the graph, even if equality isn't allowed.
Yeah.
I know that's a lot to take in, and I hate to do this, but I'm going to ask. Any questions?
Oh.
Let's do another one.
Yes, no.
Yeah, yes. When I look at this interval, this first interval, -4 to the left, does that interval ever stop? So the leftmost part of the graph has to have an arrow and keep going. This is the leftmost part. The programmers for Pearson will do one of two things. Either they show the arrowheads, or some of the programmers, they don't show the arrowheads. They just keep the things drawn forever. That's why I continued like that. They draw it until they run out of room.
Okay.
But the way we're doing it, if the interval keeps going forever on the left, then the left side of the graph has an arrowhead. If it keeps going forever to the right, this interval,
5, 6,
7, 8, 9, 10, 50
11.
million. So the right-hand side has to keep going. You have an arrow on the right.
But I don't think you even see the arrows.
I don't think they even show the arrows here.
Okay, let's see.
Well, they do show the arrows.
Oh, they
A,
do. Is it A?
clearly
Oh, no.
not.
Okay.
B,
Is it B? Oh, no.
that's a pretty graph, but that's not our
Not
graph. C,
Let's go with the D.
D,
Is it D?
no,
No.
it better be C.
Is it C? Let's look. See, they're showing.
Okay, they have the open circle where we need it. Open circle.
I'm trying to make it bigger.
There. Open circle, and
You'll tell.
then the line
I
segment.
made it too small, too big.
So you have two rays. That's what these things here, it's called an open ray because the starting point is open. You have two open rays and a line segment. Response C.
Oh yeah, let me choose that. We get back to normal. So response C. Oh, all of that just to say response C. Okay. Are we ready to try graphing another one? You've got to plot these cut points. And those go with either open or closed circles.
Any x values you choose on your own have to be regular closed dots. You cannot have a graph with half a dozen little open circles appearing along it, okay? The only time you can have an open circle is when you're plugging in a cut point for which there's no equality. Let's go back to number 5. Maybe this is a smaller function. And it is, okay? It's a two-piece function. They want us to graph f of x equals, the y value is -3 if x is less than or equal to -2, And it is a negative 2 if x is greater than negative 2. Okay. In this case, I'm only going to have 2 pieces to draw. What's my cut point? Where does the top piece change to the bottom piece? Where does the black piece change to the blue piece? If you can tell the colors, black and blue. At what x value? It should be obvious. At negative 2. Negative 2 is my cut point. Okay, I'm going to make 2 tables of values. Table 1 and table 2. Yes, I numbered the tables. So table 1. The first number, I don't have a choice. The first number I must use for x is negative 2. That's in the inequality. That's a cut point. Now, is that going to be an open circle? No, because there is equality. It'll just be a plain closed dot. I need another number, a number smaller than negative 2. Negative 3, I think I'll use negative 4 just to spread the points out some, okay? But negative 3 is fine. Now remember, any x value you choose on your own is automatically a plain closed dot. The closed dot means the number satisfies the inequality. You wouldn't have chosen 5 because 5 isn't less than negative 2. The numbers you choose have to satisfy the inequality and are therefore plain closed dots. Oh, I like this. It's constant. There's no variable to plug in. What are these y values going to be? Negative 3. You know something? Let's make the second table right now also. And then we'll draw the grid and graph the pieces. What's the first number I must use for x? I have to use negative 2 because it's a cut point. It's there in the inequality. But since there's no equality, what am I going to do?
Open or closed?
It'll be labeled with an open circle. I need another x value, a number that's actually greater than negative 2.
Negative 1, 0.
I could use negative 1. I could use 0. I think I'll use 0. Is that going to be an open circle? No, the numbers you choose are plain closed dots. But either way, what are these y values? Negative 2. So I draw my XY grid. Oh, this is nice. I have to count so far up and down.
Yeah.
So we have to clearly label negative 2 on our x-axis. There's negative 2. That's where the pieces are going to change.
From a black graph to a blue graph.
That looks all black to me. Even the green. Can y'all tell I'm using green there? Yeah.
Well, I've ordered new pens, so that'll give us something to look forward to.
1.0, 2.0, I hope. White
yes,
ones.
1.0.
Okay. Okay. That gives me something to look forward to.
Isn't that sad?
Actually, I'm looking forward to dinner.
Oh, well.
Okay. So, we go to the point negative 2, negative 3. 1, 2, 3. And that's a regular closed dot. Then we go to negative 4, negative 3. There's negative 4, down negative 3. The graph starts at the cut point. It can't continue the other direction, okay? The cut point, it starts there. It goes towards the left. Does it stop? No, the interval x less than negative 2 doesn't stop, so the graph doesn't stop. With regards to arrowheads, you can only have one arrowhead on the leftmost and one arrowhead on the rightmost. So now the blue piece. We go to -2, -2. That's an open circle there. Then 0, -2. The graph starts at that open circle and it goes to the right. Does it stop? No, it keeps going. The only way it stops is if the interval is like one of these compound inequalities where x is between two numbers. That's when they stop. But if there's only one number within the inequality, one side, either the left or right, is going to have the arrowheads.
C. Now,
A, B, C, or D.
okay, let me pull up these. And let's see. A.
No.
No, what's wrong with? Oh, well, it's just wrong. The O.
B.
B.
That looks.
Oh, it almost looks right,
Oh,
but
it does.
what's wrong? Can y'all see? Do I need to blow it up?
Blow it up. There it is.
Do y'all see what's wrong? Oh. Oh, shoot.
Okay, they've swapped the open and closed circles. Switched our paper. There they have the closed on top and the open on the bottom, but it should be an open and open on top, closed on the bottom. They reversed the open and closed circles. What about C?
C. Let's see.
I
Is
think
that
it's
it?
C.
I'm thinking it's C. Do y'all want to look at D just to knock it out? Yeah, it's not D. Okay.
Response C. Pay attention to those open and closed circles. Okay. Number 3.
Number 6 was the only one with the 3 pieces, if I'm recalling correctly. And I like to do those first just because, oh wow, if you get that, then the other ones are easy. And you see the pattern better, I think, with 3.
I think so too.
Past semesters, I've tried doing the two-piece ones first. You don't really see that pattern that way.
And this is a two-piece function. What's my cut point? Where is the black piece going to change to the blue piece when x is equal to -3? So I'll make my table of values. This is table 1. What's the first number I have to use for x in table 1? I have to use that cut point, -3.
Open or close circle.
Closed because there is equality. Now I need an x value less than -3. Can I use 0? No, less than. I tricked you.
Okay. To the left
of -3. What do you think I should use?
-4.
-4?
-6.
Okay. And that's the numbers you choose on your own are automatically closed dots, because you can't choose a number that doesn't satisfy the inequality. Well, you can, but you'll get the wrong graph. Plug in -3 into the black piece. -3 minus 2 gives us a -5, okay. Plug in -4. -4 minus 2. -3 minus 2 gave us a -5. What about -4 minus 2? -6. Let's make our second table while we're at it. What's the first number I must use for x? I have to use -3, but since there's no equality there for x, what will I use? Open circle. And what do y'all want to use for x? You need a secondary point. You need 2 points.
-3, -2, -1.
What do y'all
0.
think I'm going to write here? 0, I agree. In that event, the y values are both -5.
I like those constant functions where there's
Nothing to plug into, I know. Funny thing is, students don't like them. I draw my XY grid. Okay, so I go to -3, -5, left 3, down 5. I have a closed dot there. Left 3, down 5. Then left 4, down 6, right there. You start drawing at the cut point. So you start here. You start drawing there. Do you stop? No, the interval keeps going. So you have to keep going. And you wonder, well, how do I know which direction to go? You start at the cut point. You go towards the other point. There's only one way you can go. If you're starting at the cut point and you're going towards the other point, you got to keep on going in that direction.
And if you look at this, the symbol's pointing which way you keep going.
Keep going to the left.
Okay?
You're right.
It's just going to keep going to the left. Right here, it'll go to the right.
Now I see why we're doing this problem, okay? I see why we're doing it.
Something unusual.
But something unusual is about to happen. You have to understand, that that open circle says this point isn't on the graph. So you're going to -3, -5, expecting to put yourself an open circle there, and what do you discover? You already have a closed circle. -3, -5 isn't on the blue piece, but it's on the black piece. If you have an open and closed circle appearing at the same spot, closed circles take precedence. I go there expecting to put an open circle. It's already got a closed circle. It stays a closed circle. Now, if you have an open and circle appearing at the same spot,
Open and closed circle appearing at the same spot.
If you have an open and a closed one appearing at the same spot, your graph will have a closed circle, a regular dot. And then, without thinking, I went ahead and plotted the other point and kept the graph going. How did I know that it was going to keep going forever? Because this interval never stops. The only ones that don't have any arrowheads are the ones have a starting and stopping point, like that middle interval on problem number 6. Otherwise, the left side will have an arrow, the right side will have an arrow.
Let's see these choices.
If you have an open and a closed circle appearing at the same spot, then you have an open. You have a closed circle on the graph. It's not B. What about C? Is it C? I think. Oh, what about A? Why do you skip past A? Is it A?
No.
No.
Is it D?
No.
Has every one of these been C? If in doubt, just guess C. I think.
Yeah, there it is. That's it. Notice it has a closed dot there at that vertex.
Each little mark is 2. 2, 4.
Oh, you're right.
So there's 5. Okay.
That's it.
Okay, so C. Any questions there? If you can graph a piecewise function, if you understand how we're doing this, you have a very, very, very firm understanding of graphing. Okay.
Let's see.
Oh, you want to do another one?
Let's do another one.
Okay.
1 and 2 are just evaluating, okay? What about this one? This one looks good.
Oh, okay. Let's do this one. So this will be the last one, number 4. Unless he decides to do another one.
Oh, goodness. Okay, we'll use negative 3 minus x if x is less than or equal to 1. And we'll use negative 3 plus 2x if x is greater than 1. I remember graphing these in a 1324 class once, and people asking me, what was the significance? Sometimes I just put a comma. Sometimes I just put a comma, and other times I'd write if or for. It's just whatever I feel like. I mean, when I was feeling lazy, I could just put a comma there. That suffices. Okay. Where's my cut point? Where will the black piece change to the blue piece? At 1. So we'll clearly need to label 1 on the x-axis when we draw our xy grid. I'm going to make 2 tables of values, tables 1 and 2. For table 1, what's the first number I have to plug in for x? 1. That's 1 is the cut point. Will this cut point be open or will it be closed? It will be a closed dot because equality is allowed. We need another x value. Can I use 2? It's a number less than 1, so you better use negative 2. You could use 0, so I'm going to use 0.
But negative 2 would be a good thing.
Negative 2,
a bigger graph.
It'd give you a bigger graph and more space between.
Graph.
Yeah, the points are going to be jammed together, aren't they? So, well, plugging in 1, negative 3 minus 1, that's giving me a y value of, and that's a negative 4. Plugging in 0, negative 3 minus 0 gives me a y value of negative 3. Now my second table, what's the first number I have to plug in? 1. I look at the inequality and what do I conclude? Now, realize you cannot have 2 closed circles above one another, because then it would fail the vertical line test. That's one thing I haven't mentioned, but if this had been a closed circle right here, with that closed circle, you could draw a vertical line so that it intersects it twice, not a function. We know these things are functions.
How
So,
do we know?
because they're telling us right there, that function notation is saying this has to pass the vertical line test. So you cannot have 2 closed circles above one another. You can have 2 open circles above one another. That's okay, because then neither of those points are on the graph.
For the same reason, you can't continue that graph. If you continued either one of these horizontal lines,
If you continued this black line this way, then it's not a function. It's intersecting. A vertical line will intersect the graph in 2 spots. So keep in mind what you know about functions. Okay, we need another x value. What do y'all want to use for this blue piece? 2, okay. Plugging in 1, we get a negative 3 plus 2 times 1 is 2. What's that going to give me?
negative 3.
Negative 1, okay.
Negative 1.
Plugging in 2, we have a negative 3 plus 2 times 2 is 4, which gives me a positive 1. So make sure we've labeled 1 very clearly on the x-axis. That's where the pieces are going to change. Where's my black pen? Here. Okay. We go right 1, down 4. 1, 2, 3, 4. We have a closed dot. There's -4. Then left, right, 0, down 3. Okay, y'all tell me. I have these 2 points. Do I start here and go towards the right, or do I start at the bottom point and go towards the left? Okay, you start at the cut point. 1, -4, that's where you start, and you go towards the other point. Am I going to stop, or am I going to have arrowheads? It's going to keep going. I'll have arrowheads. Now the blue piece. 1, -1, right 1, down 1. We have an open circle. Then 2, 1. There's 2 and there's 1. Just a plain closed dot. Am I going to start at the closed dot and go towards the open circle, or am I going to start at the open circle and go towards the closed dot? Start at the open circle. Am I going to stop? No. Keeps going forever. The only way your graph stops is if the interval has those 2 numbers between it, like number 6 did. X was bounded between -4 and +5. That graph, it didn't have any arrowheads. It started and it stopped at the cut points. Oh, goodness.
Let me see which one is
A, B, C, or D.
Can y'all see it good enough to
Can
tell?
y'all tell us? Can y'all see which one it is, and just tell us so Tony doesn't have to go through all of them?
Well, it's not
Because he
C.
always chooses the wrong ones. He always chooses the wrong ones to look at.
And it's not D either.
Okay, it's A.
It's A, yeah.
Yes, it is. Okay. Response A.
Okay. Any questions?
Okay, that's.
Oh, I'm gonna go. Hey, it didn't freeze.
Yeah. So maybe you were right.
Yeah.